So hopefully you can actually see the introduction slide. But when I am traveling, sometimes what I often like to do before we get into the weeds of the presentation is start with a little geography lesson. So if this works, what I might do is bring up a website that is called the Antipode Finder. Now, antipode is the term for locating the point on the complete opposite side of the planet to a given point. So if we pop in the word Exeter, which is where I'm potentially, am tonight, we can actually find out, well, what is the opposite side of the planet to Exeter? And if we focus in down here, go get rid of some ads, you'll notice that there are two pins around what you may recognize as New Zealand. So the little yellow pin happens to be the perfect opposite point, and the blue pin is the nearest populated village, town, city, whichever. Now, I actually live here in Wellington normally, so I'm not too far from almost the complete opposite side of the planet to the user group tonight. But the planet's small, and it's wonderful to see so many people from all over the place. The other little geography one I have fun with is there's a website called The True Size Of. And what you can do with that is punch in the name of a country, and you can drag the country around because usually the maps we look at are distorted, to deal with the Cartesian way to display a map. So often when there's maybe some event taking place in the South Pacific, some people might reach out and go, "Oh, how are you right, Phil, on that small, tiny island in the middle of the South Pacific?" But if we actually put the country of New Zealand superimposed over the UK, you can actually see it's not that small necessarily. You can spin the country around and get a like-for-like comparison. Anyway, that's enough of the geography lesson.
I love I love both of those. They're brilliant.
I can share them in the chat later.
Yeah.
I'm not spectacularly good at multitasking, but let's get back to debug DAX like a pro. So what's in our agenda? So I don't have a big agenda. We're just going to talk a little bit about why I decided to put this presentation together. We're going to dive into the anatomy of a Power BI DAX query, and this is quite important to know your enemy. If you're going to figure out, debug, optimize, it's quite good to know what's important and what's not important to help you perhaps focus and speed up your exercise of debugging. I've got a little exercise where I deliberately start with a bad report, and we'll go through the steps that I normally do, and hopefully that gives you some ideas, tips, and then we can set aside some time for questions at the end. So why did I put this slide together? So the background was the catchphrase, "Yo," who hopefully most of you will recognize as Guy in a Cube. So I work on the same team as Adam and Patrick, or certainly did a few years ago, when I got a call out of the blue from, I think it was Adam. I can't actually remember. It was a few years back now, and he was quite excited because he had been on a call with a customer and managed to help them with some best practice tips and ideas. And I think they'd managed to get a query that was taking 40 odd seconds down to about 5 seconds. And, he was pretty happy with that. And sort of went through what he had walk through with this customer, and I thought, hey, we can possibly do better than that. And I showed Adam some techniques that you can do with DAX Studio, and he went away and tried them out, and sure enough, we managed to get the query down under a second, which doesn't sound like a lot, but sometimes those last bits are the hardest one to do. So then he got on the phone to Patrick and went through what I'd shown him, and Patrick, sure enough, had the opportunity to do the same exercise with a different customer and had similar results. So they were both pretty excited. We even did a video on this a while ago, but the penny dropped to me that, well, hey, if I'm showing these legends, and they were already at this point, these tips and tricks about how to approach maybe optimizing a DAX query, then I should really put this into a presentation. So that's the background a little bit to what we're doing today. So I thought we might start with a little bit of an anatomy of a Power BI report, and I should really open my PBIX file. I was supposed to do this before the session, so I'm going to fire this up on another screen and bring it up.
It's my fault. I started chatting.
No. Yeah, I got distracted. I was too excited to present. So I believe I've double clicked. I'll try it again. There we go. I think I've got the sand timer spinning. So a lot of people think DAX is perhaps what you put in a measure. So when you open a model and you create a measure and you write some DAX, like a period comparison, a running total, or a rank measure, or a child to parent ratio, that's it. That is the actual DAX measure. But it's not. The measure typically gets put inside a much bigger series of DAX that Power BI writes for you. So when you drag columns to a visual and you drag measures to a visual and start formatting, etc., what's happening under the covers is Power BI is generating a much larger set of DAX instructions that maybe reference that measure that you built. So it's really important to understand what Power BI desktop is doing, or Power BI service is doing, every time you load a report. And that's why we want to actually focus in on that to figure out what's going on. I'm just still loading up my Power BI report.
Oh, no.
Teams is always
yeah, when you've got Teams and Power BI, it always makes it a little bit slower.
Slower to go. I'm actually also on hotel Wi-Fi, so we'll let this go a little bit. Although that shouldn't affect that should not be slowing us down here.
Yeah.
And if it takes too much longer, I may have to dive down into my awful bag of dad jokes. Let's hope it turns up. I'm actually going to turn my.
Yeah, we were just discussing before we went live. Phil's written 2 books on DAX, and one of which is based on database developers. So that was quite interesting.
I'm just getting
to
the
come,
point.
Phil.
I'm actually just tabbing across to my CPU settings and making sure I've got my CPU set on max and making sure everything's plugged in nicely, but that's just spinning too.
They're having a conversation in the chat about using Tablet Editor 3 for debugging DAX. I've done a video on it using DAX Debugger. It's on the YouTube, so we'll pop the YouTube happened as well. So
I think it has actually started, but I'm still going to set this to be the fastest. Wonderful. Yeah. Okay, so you can drag the screen up.
And Mark said his slow opened happened to him yesterday when he got a new download. So
well, hopefully I haven't got a new download. There we go. Let's just bring this up.
There we go. Brilliant.
There we go. So one of the things we can do is start the Performance Analyzer here in Power BI Desktop. Now, one of the tips I'm actually going to give to you is when you're properly doing your optimization of your DAX measures, I recommend you optimizing against a version of the model that's hosted in the Power BI web service. And that's because the web service engine is slightly different to maybe Power BI Desktop. Not a lot, but sometimes enough to make it important. So where the Power BI Desktop version might run some things in series, the service might do in parallel. So if you optimize in desktop and then wonder why it's maybe different in the service, that could be an explanation. I'm going to stick to the desktop here tonight because, hey, it's fast. But I'm going to start the Performance Analyzer, and I'm going to start dragging some calculations to the desktop. So if we find a sales amount measure or a sales amount, say total sales, cool. And actually if we start this and refresh this, best performance, I can actually turn my CPU up now. Cool, wonderful. So let's just run a DAX query. And what we can see over here on the Performance Analyzer is some information, including the ability to have a look at that DAX. We can either copy the query, which puts it into our copy buffer, and we can jump over to a tool like DAX Studio. Or we can now, which is sort of reasonably recent, have a look at that DAX and DAX query view. And I just want to do that first. So to simply drag a measure onto the canvas and display a single number in a card, we don't have to write sophisticated DAX. And this is not typical. You're not normally going to be doing lots and lots of these types of visuals. There's going to be a lot more DAX involved wrapping around what we're really showing, which is the total sales measure. So let's jump back to the canvas and do that. So what I'd like to do is maybe calendar year. We'll pop onto the canvas and turn that into a slicer. And if we format the slicer to be a drop-down list, slicer settings, because I don't have too many values, actually we can make it a list, a vertical list. Nice. Well, I'll rearrange my screen shortly. Let's go product name, brand name maybe. Cool. And I'm also going to put maybe country, county, sales territory, county into the filter panel. I think I dropped that into the wrong place. Filters on this page. Sales territory, there we go. Should probably do the undo format. We're going to filter this by Texas or something else. South Korea. Wonderful. In 2008. And in this slicer, I probably want to remove sales territory. Okay, I see what I did. There we go. I am not a data-viz person, as you can possibly tell. But while all that activity has been taking place, what's been happening is we've been issuing, every time I've performed an action, another DAX query. So if we bring back the Performance Analyzer, and I'll clear it, and I'm going to click the Analyze This Visual option in the header for this visual, I can capture that DAX. And let's have a look at this one over in the DAX query view, because this is now going to be a little bit more interesting. So the anatomy is I used a filter in the filter panel, and that's showing up here in the filter table. Sometimes you have multiple versions of these. The main function I'm looking for at this point in time is summarize columns, which is this one here. That's generally the engine room of a typical DAX query. And the way the summarize columns function works, I'm going to enter these down to format them, is you can pass parameters to it. The first type of parameter that it may expect to see is a column reference. And you can pass no column reference, or one like I've done here, or you could pass multiple column references. And the purpose of a column reference when it's used in summarize columns is to provide the grouping. So because I've put the brand name column into summarize columns, what that's going to do is it's going to give me a result set that has one row for every relevant brand name. And maybe if I've got 10 brand names, I'll get 10 rows. And if I keep passing column parameters, that just gives you additional levels of grouping. So year, month, day, they don't have to be from the same table, etc., but they'll appear here. Then if we stop passing column references and we start passing tables, like we have done here, because this is a treat as function returns a table that gets stored into this variable. When we start passing tables act as filters. So, and you can have no filters, or you could have multiple. So the fact that we said we want to only look at data for South Korea, that's getting stored into this table. The table gets put inside these summarized columns so that this becomes the equivalent of your where clause. And then finally, we have a set of potentially multiple measures. In our case, it's one measure, but it's the summarized columns that we typically like to focus on, because that's probably where the issue is going to be. And that's what we can do to help figure out where things are maybe running fast or maybe running slowly. After the summarized columns, we're really just doing some cosmetic things. So what's happened here is we go into our fact table, we are filtering the rows down to the relevant rows based on the filter that we're applying. On those rows, we're performing some calculations, and they're going to get grouped into various buckets, and that's going to produce a table, which we store into a variable. Whoop, that zoomed in. And down here at the bottom, we're just doing some filtering to say, let's, for the purpose of the visual, only show the top 1,000 rows. And if I think you scroll, or depending on the visual, that'll go and get some more data. But I'm really interested in probably everything down to about there to know whether this is going to be a fast or slow query. Sometimes you might see multiple summarized columns, and that could be a reason to raise a red flag. So one way that might happen is if over in the filter panel, perhaps I've assigned a filter to say I only want to see the top 5 brand names or the top 5 sales territory countries. In fact, let's do that just to show you what that might look like. So basic filtering or advanced filtering, is this going to give me top 5? I forget how to do that in Power BI. Basic filtering, no, there must be a different way that you can do that. Perhaps it's on a different column, but if you do apply a top 5, then what can happen over here in the DAX query is, first of all, it performs a query, has to be on the visual filter. Great. I sort of caught that out of the corner of my eye. So what we'll do is we'll go, let's go region country and put that on the visual. And top N, wonderful. Top 5 by, doesn't have to be by sales, but we'll see if we can find that same measure. Total sales and apply. I'm using a different column here. So there's some cross-filtering going on here. Doesn't matter. And in fact, what we'll do is we'll even click a particular year, clear this, go and grab this DAX again, run this in DAX Query View. Okay, so if you remember what we just talked about, now we've got a filter of 2016 on calendar year. We're doing a query here to say, give me a table of geographies, like every single possible geography. And there might be 100, there might be 1,000. But go and run that query and pretty much calculate the total sales for every single relevant value that we're grouping by. And now underneath that, we're going to take that big query and limit it down to just the top 5. So we'll effectively sort them and grab the top 5. And then this is the variable that's now going to be used as an additional filter. So now we're actually into the query that's going to produce the right results for the visual. We're grouping by brand, but we're now providing 2 visuals. And often what happens is we are doing the similar grouping. So we're more likely to be doing a top 5 on the same brand. I did something a bit daft and just dragging to keep things quick. But this can actually often double the size of your DAX query. So just sometimes what I might say is, hey, if your query is taking 20 seconds and you've got a top 5, even though it's counterintuitive, even though you think that should reduce the time it takes, it sometimes doubles it. So if you temporarily turn off top 5 and take a duration and a compute measurement, sometimes it just halves. Now that's not the solution. You actually probably want to do that, but there are other techniques that you can apply, like baking it into the measure or doing DAX Fusion, which we're not necessarily going to dive into too deeply tonight, but do keep an eye. The tip is really, when you're looking at the DAX, just see if there are 2 summarized columns going on and what the first one's doing and how much work is involved in that first one. And potentially it might be just duplicating a lot of things unnecessarily that you can find another approach for. So, but that's what we're really going to look for. So my optimization exercise is basically, imagine you've got a colleague. Oh yeah, we've got a question, or
we got a question. You said to interrupt you, so I'm taking you at your word.
Yes, please. Yeah.
So it was, is it possible to clear the query cache in Power BI desktop on the optimizer pane?
No, I don't believe you can. That is a great suggestion, and I'm pretty sure we have discussed this in the past, but it just, for whatever reason, hasn't quite got out there. You can clear the cache by doing that in DAX Studio, but the other challenge you've got with Power BI Desktop is there is a visual cache. So even if I do clear the cache and I tab off this page and tab back on, it will probably snap up. The best way to do it, to be absolutely sure, is to, unfortunately, close the app. And quite a common technique is just create a blank starting page and save the Power BI Desktop in that format, close it, reopen it on blank, and then go to the page. And that way you're going to get the effect of cold cache performance metrics and bits and pieces. So that's just one thing to factor in.
Yeah.
So
thank you.
So Phil, so the clear part under the Performance Analyzer there, that will,
this button here.
Yeah. So that will clear. Will that clear the cache out then?
No. All that does is clear out this activity. So I'm clicking down on some changes here, and I'm clicking on some wedges. And as you see, every time I do something, I'm getting activity here, but there'll be a point where it starts having to scroll. And if I don't want that anymore, I just click the clear button here, and it just empties this again. So I'm now back in, I can see what's going on. So the button here called clear is nothing to do with cache.
Okay.
All it is about is just tidying up the Performance Analyzer window. And you do have to be mindful of cache, because one of the things, if you are optimizing for performance, is if you don't clear the cache appropriately, sometimes you might think you're getting good results because you have optimized the DAX, but it might actually simply be because you're hitting clear the cache. And when I jump over to DAX Studio, which I'll do shortly, I'll show you the button on the ribbon that you can do to make sure that's running every single time. But also be mindful that that's the worst case scenario. When your users are using the report and they're hitting pages that a colleague has recently hit, they're going to get the benefit of cache and they're going to get the correct numbers. So the chances are they might get snappier experience than what you're seeing with clear cache. But if you are optimizing for performance, it's always probably good to go for the worst case scenario and try and get that down as much as possible, and know that it should hopefully be no worse than that, and potentially only better if users are actually hitting the query cache or the visual cache. There's a few things going on, so we will definitely do that.
And Dominic said he's had arguments about top 5 as well in the office, the amount of arguments he's had. So
yeah. It can be done. Fusion's one approach. You can bake it into the measure. Sometimes if you do that, it's not so flexible and dynamic. You can have disconnected tables. There's a few techniques that you can do, but I would always be mindful to just look at the steps that I'm about to show you, just to see if it is in fact making a difference and improving your performance.
Brilliant, thank you.
So for my optimization exercise, what I'm going to do is we're just going to pretend that a colleague has come to you and said, hey, I've put together this Power BI report. I think I've followed best practice. It's running okay. Is there anything you can do to help me speed that up? So as I mentioned, we'll start the Performance Analyzer. And what I'm going to do is click on the page and just load it up. Okay, so how's it going? It's spinning, it's spinning, it's spinning. We had a matrix that took 4 seconds, which is not especially slow. This used to be a lot slower, actually. We have baked into the engine some optimizations that can help this. Now, there's a couple of things going on this page. First of all, the visual that's the slowest is a matrix, and I can click on this and it actually highlights it. I can click on the card and you can see which card each one relates to by the focus, for example. But usually the slowest visual on any Power BI report is going to be a matrix, because often it involves multiple measures with multiple calculations and grouped by many different complex things, and there can be an awful lot going on. And there's actually scroll bars here that show that if I was to zoom back out, there's a lot of numbers going on. These individual cards didn't take a lot of time to spin up, but I've also got a tip to sort of show you how you might be able to speed that up. But let's copy this query, and copy query captures the DAX for this matrix, and we're going to jump over to DAX Studio and have a look to see if we can possibly speed this up. and I'm opening that up.
Just where you're opening it up and you're breathing, quick question. Do you ever optimize for worse initial performance but better cache performance?
No, generally, no. I usually just focus on the worst case, the cold cache, having the cache cleared. And so I just assume that if we can get that to 1 or 2 seconds, then it's only going to get better from there. So it's not something we've generally needed to focus on. I'm going to paste this query in before I lose it. Okay, so it's quite long. So this is what I mean. This is what Power BI actually generates on your behalf when the visual is being loaded. And this piece of text, which is 100 lines, this gets sent as text to the actual database engine, like as a query, and then the database engine has to resolve it and return a result set. And then Power BI takes the result set and uses the information in that result set to draw SVG and render the actual visual. But that turnaround time is what we want to focus on. So there's a couple of things here in the DAX Studio window. We're connected to the model directly. There are some buttons on the ribbon here, such as clear cache on run. You can toggle that on or off. I like to have it on. That means every single time I run a query, it's going to clear the cache. So I'm always going to get that cold cache performance when I'm messing around and trying different techniques. Whoop, we better put that back on again.
There's just another quick one. How many columns and how many records in the fact table?
It's probably, we can tell that in DAX Studio. So we can go to the Advanced tab and we can do a view metrics. So this is sometimes called a Vertipack Analyzer. And this is telling me that the largest table has 25 million rows. It's using 320 megabytes. So total size is all about megabytes. And I can have a look to see how big each individual column is, which can be important for advanced analytics. I can see the encoding type. There's some really useful information here especially if the model size gets very large, it can help give you ideas and tips on how to approach this. There are 24 segments. So in this particular model, what's happened is when the data is being read in from the system, from the source, it's read it in batches of 1 million rows at a time. And it's taken those 1 million rows, it's shuffled them, it's pulled apart the columns, it's done run length encoding, bit packing, and it's put it into a packet of data in the engine called a segment. And because I have 25 million rows, it's decided that it can pack that into 24 segments. And when it comes time to run a query, and this is quite important, if a column like sales amount is relevant to that query, what will happen is we will open all 24 segments and we will jump to the part inside each segment that's relevant for sales amount, and we will scan all of the data. So we will read all 23 megs of data in every single query. It doesn't matter if I'm saying I just want to look at sales for the previous month, or even if I just want to look at the sales for this morning. When I say I want to sum sales, filtered by whatever, I still need to open all 24 segments. And this happens in parallel. So if you happen to have a machine with multiple cores, which most of us generally do, I think my machine has maybe 8 cores. So I can spread those segments out across the various segments, cores, and they can run in parallel, and they can just scan memory and return the appropriate results. They apply filtering and grouping as part of the same approach. But when you're in the service, those Power BI service have got a lot more cores. So sometimes that can speed that up quite significantly.
That was one of the questions in the chat, and someone had answered and said there was better service on Power BI service. It could be better resources. And there was another quick question. Does the query or visual cache get dumped if a semantic model is evicted on the service?
I don't know, sorry. I would have to assume it probably does, but I can't say for sure. So hopefully it does actually send the signal to go away. And you could test that because if you reframe the model, then if you change some data, reframe the model to evict all the columns, and then just go quickly back to your Power BI report, I'm pretty sure that signal will have made it all the way through to say, no, we need to go and get some fresh data, be it import paging in or direct lake paging in.
Okay, just one more.
So,
is the data local, or is the database being queried directly?
in this exercise, this is an import model. So this is just all baked inside my PBIX file. It's not especially large, but we still, only on a tiny data set with only 25 million rows, took 4 seconds to do that matrix. So we do want to see if we can figure out if there's anything in there that we can speed up. So what I want to do is have a look at the DAX that Power BI generated. And remember, I mentioned that I look for the summarized columns. And here we are at line 19 is our summarized columns. There happen to be 4 filters going on above that. They get the unimaginative name filter table 2, filter table 3, filter table 4. It's almost as if they borrowed my very, very rare and unusual naming convention. But there they are. So in the summarized columns, lines 20 through 24 all happen to be column references. They are wrapped in this roll-up set of DAX functions. That's all handling subtotals and totals, because as a matrix visual, we want to have various lines in between the expanded grains to do subtotals, totals, and grand totals, etc. But everything I've highlighted here in red are the column names. So we've got calendar year, we've got month name, and month name underneath the covers is sorted by the month number to make sure that we don't have April and August at the top. They are actually January, February, March. And we also have sales territory name. That's what's been put onto the row header in this particular case. Then the next, then the next 4 rows underneath that, these all happen to be tables, because it's got table in the name, and we're coming from here. So we're applying the various filters on our columns in our dimension tables, and we've got 3 columns here. So what I want to do is my other favorite button in DAX Studio is the server timings. So those of us who come from a SQL world probably are familiar with SSMS SQL Profiler. And underneath the covers, it's really just running a little mini trace against the database engine just to watch what's going on. It focuses just on the query that gets executed here, but it tells us some really interesting information about what goes on under the covers. And I've got a little red flashing light here. So what I'm going to do is run my DAX query and see what's going on here. So run the query in single user mode.
I used your blog post on Profiler when Chris Webb did a session on it a couple of years ago, and it was just brilliant to see how each query ran, and then that is when I was learning, and I realized then that Vertipack works from the bottom up. The queries read from the bottom up. So I'd been doing something to pull out a dimension, but because it was going through every single step, it took forever. So that saved me a huge amount of time.
Oh, that's good. Now so this query, even though there's 100 lines of data, still just produces a single result. Well, actually 2. One's this is the main result. So here's all our sales and distinct customers and column indexes, etc. So the server timings, it's telling me. So down here, there's a really interesting box. I'll focus on that a little better actually here. So everything in this box is probably now what I want to start looking at. So we know that the elapsed time, the total duration was 5 seconds, but it actually used 13 seconds of server time. So this is that scanning all those segments, getting spread across multiple cores running in parallel. We used quite a bit more compute to produce this query. Down here is the really important one. How many times did we make a storage engine query? SE in this context stands for storage engine. There are 2 engines inside analysis services. There's the formula engine and the storage engine. And the analogy that I like that works for me is the storage engine is all about just going to get the data. So let's say you needed to bake a cake and the cake had 10 ingredients. Now, what you don't want to do is make 10 separate trips to the store to get 1 ingredient per trip. ideally what you want to do is make a single trip to the store and get all 10 ingredients in that one round trip. So here, what we effectively did to bake our cake is we made 166 separate trips to the supermarket to get all the ingredients. Now, once we have all the ingredients, that's when the formula engine can kick in. Now, there's only one formula engine. There's only one chef. In other words, the formula engine is single-threaded. So once we have the data back, the formula engine steps in and can do some, but not necessarily all the work that has been asked to do by what's been coded into the measure. Some work can be done by the storage engine. So if we're doing some pretty basic stuff like counts or sums, quite often what we can do when we're scanning the aisles in the supermarket, we can add stuff up as we go, and then we can just report back to the formula engine a number. And the formula engine doesn't have to do too much work. But another scenario is what we actually have to do is get an armful of ingredients and bring it back. So the formula engine has to do some work. And in this case, the storage engine is doing some work, but not all of the work. Sometimes you see this very, very tiny, and all the work is in the storage engine, and vice versa. But that's where the two engines are going. But I'm not so worried about that just yet. What I'm worried about is this number. 166 is high. I get nervous if that's above 20. In fact, I'd like to see it above 10. And if I've done my job well and I do things like DAX Fusion or really optimize the visual, we should only have a single round trip to the storage engine. And ideally what that's going to be doing is getting a data set that just has the bare minimum number of rows and the bare minimum number of columns. So how do we figure out what's going on? Well, let's just do some old school debugging. So I could perhaps maybe comment out this measure and rerun. Remember what these numbers look like. Okay. So that's taking, that was a bit quicker, but I think that might just be some CPU things going on. But the fact that this is taking a long time to draw up the query end events probably indicates that we haven't made too much difference in this particular measure. And I know it is just really doing a simple sum. So nothing really changed. It did run a little faster. That's possibly some CPU stuff on my machine, but we can definitely do faster. Now, if I go down these storage engine scans, I can click on each one of them individually just to see what's going on. And I do notice now a lot of them are doing a repetitious, repeating a pattern here. I can see the word decount, which always is a bit of a worry. And if I scroll down, make this a bit bigger, I wonder if even anything's changing here. Yep, so it's basically doing a distinct count for slightly different values in the date column. And there's lots and lots and lots of these decount calculations. And I notice if I look quite carefully at the measures, one of them even has the word distinct in the name of the measure. So let's try and see what happens if we remove that from the query. So I'll even put this one back again. Total quantity, and maybe get rid of that comma and rerun. Okay, so believe it or not, the query is actually completed, and we can focus on what's happening with the server timings. It's shrunk down to just 2 storage engine events. The total amount of time was tiny, and this is with clear cache, remember. You know, the storage engine and formula engine work were barely noticeable. So pretty fast, and we can even see what they're doing. One's just organizing the group of customers, and then the other's doing sums of multiple columns grouped by the appropriate columns, and there will even be a where clause with all the other things going on. So this is fast. So what we've actually done is figure out that I can go back to my colleague and say, just remove that one measure, don't do a distinct count, problem solved. But unfortunately, we probably do need that measure. So we should probably dive into it a little bit and see if we can optimize that measure and maybe do it a different way to see what's going on. Now, one of my favorite feature of DAX Studio, and this is probably the one tip you can take away from here, is if I copy the name of the measure, take it over here to the Object Explorer and paste it in, it'll filter the object model. And what I can do is right-click on the measure and say define dependent measures. And what that should do is bring a copy of the text of that measure here locally into my DAX Studio window. So this is all in scope of DAX Studio. It's not changing the model. Anything I do here is all locally, but what it does mean is when I run the measure here now, it's not using the version of the DAX in the model. It's actually using the version of DAX that's written here. But you do need to be careful, because let's say I'm calling measure A, and measure A calls measure B, and then measure B calls measure C, etc. Right? So you have this sort of nested chain going on with your measure names. If you only put measure C in here, and down here you call measure A, which does call measure C, it won't use the version here. It will only ever use the version of a measure if all of the measures in the chain exist here in this scope. So that's just something that can catch people out if they think they're modifying a measure and they locally here in DAX Studio and they run it, but it's not behaving, it's not giving them the results or the values they're expecting based on the changes that they've made. It's because you need to make sure that you have all of the parent measures here as well, even if you're not necessarily running them. So it's a bit of a security thing just to make sure we're doing the right job. So we've got our measure now. So we can go to your favorite search engine and do some searching, look up the various blogs and say, hey, I wonder if there's another way that we can potentially write a distinct count type calculation. And what I'm going to do is paste in an alternative. It's not necessarily better, but we'll try it out. So in my calculate function, I might say, let's try and approach it this way. We'll use sum x. Now, I'm not necessarily saying that this should be your go-to. You should always start, if you are doing distinct count, by using the appropriate function. But this will give you the same result. So let's try that out and see what's going on. Remember, we were trying to get down from 166 storage engine events. So, oh, we're down to 16, and this is giving us all three measures. So we've made some progress. So this looks good. And I will explain why this is better a little later if we have time. But I think we can do better. Because if I scan down these storage engine events, we've got some ones here bold saying, oh, I've got callbacks on calendar, and I've got some other things going on, callback on calendar date. So I wonder if I can apply this filter, again, using some alternative techniques. And maybe I might try 3 or 4 different techniques. But let's try and write this a slightly different way. We'll highlight that and comment. Cool. And run this. And sure enough, we're down to 12 storage engine scans. That's pretty quick. The callbacks are gone. These are all pretty lightweight queries. Most of them aren't even, there's a fact table scan. There's a fact table scan. There's one. So we could actually then start going to more advanced techniques like DAX Fusion to look to see if we can bring these down to a...
What is DAX Fusion, Phil? I don't know what DAX Fusion is.
Okay, see how we've got a lot of storage engine events here that are quite similar. Maybe what if we could write DAX in a way that we could merge these together and minimize even these 12 down to 4 or 2 or even 1.
I see. Yeah.
So it's purely about trying to get this number here, the storage engine queries, down by writing your DAX in a certain way. It's a bit of an art form. Maybe another session. Although, if any of you are in Newcastle or near Newcastle in the UK, I will be in person at the user group tomorrow night, diving into DAX Fusion. So we will be spending...
I think they film it. They put it on YouTube.
Potentially, yeah. This is probably pretty good. Another tip here, I think, is one of the filters has done in a way pretty badly. So what we've got here is whoever built the report said, I want to perform search for whatever reason. I'm only interested in customers whose full name starts with A, like Andrew or Abby or Angela, etc. Now, that can be quite expensive because it's a text search. Now, if you create that as a calculated column, or better yet, I have to mention Roche's maxim sometime in my session, push it upstream. Imagine I had I introduced a column into my customer table that had that Boolean logic. So I introduced a column that did this for me. And I had prepared that earlier, for example, where the values in that column are just simply true or false. And they return true for this. It's a hard-coded thing, and false everywhere else. So it's not particularly dynamic, but let's see how this helps our storage engine event get on. And there we go. We've shaved one off, so we've sped it up a little bit. So we haven't actually got our DAX code back in the measure now, in the model now. But let's say we're happy with this. We reconcile the results and we try it with a bunch of different filters and check that we're all good to go. So we would copy this code from here and jump back to our model. And what I've done is, what was that measure called? Distinct. So distinct customers was the original version of the measure, but I have a version now called distinct customers optimized, which in my last page I've substituted in. So we can see how that performs with Performance Analyzer. But before we do that, another common pattern that I see with Power BI reports is often above or around the matrix. Maybe a series of KPIs. Like in this place, we've got 5 KPIs telling me 5 different things. Sometimes they're down the side, etc. But they're all in the same. They're all in separate visuals. So we actually have 6 visuals running DAX calculations, and I'm going to run this again. So you can see here there's 5 cards. Now they can't fuse. We talked about DAX Fusion just very briefly. They're all going to be independent, and they're actually going to run in contention with each other as well. One neat tip is to try and consolidate visuals like this as much as you possibly can. So what I've done here in this next page is taken exactly the same measures, but I've put them into a single visual. I've put them into a matrix. I've formatted the matrix to hide grid lines, and I've spaced things out. And if you place that on maybe a background of boxes that you've drawn in a Chris Hamill on my team, he had a really good example where you've got a PowerPoint where you can use the alignment to create a background very easily, save it as an image, and then bring it onto your report as a background, and then you lay this on top. You don't get exactly the same user experience, but if all you're wanting to do is just present the numbers, then it might be good enough. So what we can do now is combine...
Yeah, there are questions in the chat. They're just saying, why not use the new card visual? But I did the same before we had the new card visual. Chris's site is amazing, Alluring BI. It was a revolution when I found it.
And absolutely, the new card visual is designed to be able to do this for you now in one step without having to go to a visual that's not necessarily the ideal, and you're kind of doing a hack or a workaround to format it. So absolutely, today I'll just use the multi-card visual. It's just this this particular PBIX is about 5 years old, so it predates multi-card visual by a long way. But
but it's worth
it. The same.
It's worth it for Chris's site, because Chris's site is just awesome.
Yeah, but the multi-card visual generates one query, one DAX query that calls 5 measures. So if there is the opportunity for fusion to take place naturally, then that will happen and will be faster. The matrix here does the same thing. So the outcome is the same. The only thing is the multi-card visual gives you a rich, a better formatting experience for the the look and feel of it and the interactivity. So let's now jump to the last page. We've optimized our DAX measure. We're using a single visual for the KPIs. I've probably fixed the filters, for example, so I'll clear these here, jump on, and boom, it snaps up. Certainly a lot faster than it was running before. So in general, as my role on CAT, I quite often get pulled into scenarios where I need to help and support a customer who's got a critical report. Perhaps it's getting a lot of users hit it and it's running slow and we want to optimize it. I might need to optimize it in different ways, but the approach is typically the same. It's capturing that DAX, taking it over to DAX Studio, turning on server timings, certainly having a look at the model as well. I always look at the diagram of the model just to see what's going on with relationships, where the columns are that are getting used in the particular DAX query that we might want to optimize. I look at Vertipack Analyzer, just make sure that that's in good shape. And the best practice analyzer that you can run in Tabular Editor or now in a Fabric notebook, for example, gives you some good clues about things that are definitely wrong. But DAX Studio with server timings and studying those server timings. In fact, one day I even got Darren Gosbell, who makes this, to give me the ability to export these out. So you can take this export button, and I thought we had the ability to create all of these SE events as individual files. And what I would do is inside Visual Studio Code just actually go back and forward and forensically note what is each one grouping by, what's the where clause, what's the order that these are happening. But the starting point is always this part here, and then I can come back, bring the measure into DAX Studio, try some alternative techniques, and build up from a baseline, look to see what then the impact's having on these little mini steps that are going on here. And that's potentially where I might go down into that fusion thing that I mentioned a couple of times. Now we've got 8 minutes left before your yoga. I did promise that I would talk about why in this case did SumX work. Now, the reason why this particular approach is faster than distinct count in this case is because the values are low. So if we go back to the Power BI report and actually look at the numbers in the distinct count column, they're not especially high. Like, I'm not seeing values in here that are of the tens of thousands or hundreds of thousands. And the reason why that's important is because what SumX does is SumX as an iterator is like a for each. And it just says, I'm just going to, pop into the my iterator, whatever happens to be left over in the context after the filtering, and I'm going to step through that one by one and just increment by one. Now, because none of these values are especially high, I know that none of these loops, we never have to loop more than 300 times or 200 times, which is quite small. And this is all work that takes place in the formula engine. So we're not putting into the formula engine an especially large result set. We're not having to do too many iterations. If for whatever reason that due to my data set and due to my numbers and due to my filtering, these numbers were higher, like 20,000, 50,000 or 100,000, then what you'll find is the formula engine will now start doing a lot more work. It'll slow down, and you're much better off using distinct count in that case, because this distinct count does most of its work in the storage engine, whereas the SumX approach is much more a formula engine mix. So that's why I want to emphasize that in this case, yes, this was better. And I would probably talk to my colleague and say, hey, what are we actually distinct counting? What's the chance or the likelihood that this may actually end up being a high number, because this now might change. The pattern should stay the same, but what we might see is the formula engine activity grow in these results. So hopefully that's clarifies that a little bit. But we've got a little bit of time for questions.
Oh, look at you, pro. Anyone would think you do this for a living and you're highly experienced at presenting like this. The chat has been going mad. So do people want to ask? I've got a couple of questions saved, and we don't have to finish dot on, but we won't be far off. So, because I know you're in Copenhagen, so, there's lots of fun to have, but it's just people have just been chatting non-stop about it. So lots and lots of clap, lots of love, lots and lots of thank yous already. So one of the questions was, how do we capture record the memory each query consumes, with the lower end of Fabric SKUs having memory limitations per query? Someone's had some of the queries refresh Excel connection to the model, throw an error with resource governing.
Yep, great question. With server timings is one approach. So, and what should be included now in each trace, each query, is this concept of an execution metric. And again, Chris Weber's done quite a few blogs diving down into there, but we've got some numbers in here that talk about the peak memory consumption. So that's another good thing to actually have a little bit of a look at, especially when it comes to distinct count, because distinct count is inevitably a very memory and compute hungry calculation just by its very nature. Sums, you can derive a lot of information and you don't have to keep a lot of memory for that. But absolutely, if you are going to be using some form of distinct count type approach, then the execution metrics. Now, this is available in a classics profiler trace. If you're using log analytics or the new workspace monitoring, that should also be available. But it is included now in DAX Studio, and there's a few other interesting parts in here as well that might be of use. So,
brilliant. Another question was: have you ever increased the number of table partitions to optimize the DAX to increase parallelization?
Oh yes,
parallelization.
Yes, absolutely. And there is a good technique that can be used to speed up DAX queries, and that's to create a partition on date key. So imagine you have 2 years worth of data in your fact table. Your fact table might have 1 billion rows, for example. There's probably no point on a 25 million row table, but you're working with larger data. If you partition on date key, so you might have a partition for the 11th of February, and another one for the 12th of February, another one for the 13th of February. What that means is that partition may have one or more segments, but inside each segment, the date key value will be tiny. So we looked at Vertipack Analyzer here. The date key value will be next to nothing. And what that means is, remember I said when the DAX query runs, it has to actually open every single segment and check every single column relevant to a column being used in that DAX query. And the reason why I keep mentioning date key is because practically every analytics and reporting query has some form of date filtering, whether it's a range, period comparison, etc. So if we can perform what we effectively describe as segment elimination by just jumping to one small little part of that segment to say, is this segment relevant for my query? I can pretty much discard it straight away and move on to this next segment super quickly. Or if it is relevant, like there's a match, I now know I can use all of them. So absolutely, if you want to go to the effort of partitioning by date key, what you may find is a lot of your queries may be twice as quick with half the compute. It's a little bit more work. It's easy to do with direct lake because you can just column partition in your lakecast table, but you get the same effect. It's like it's segment partition elimination, and the benefit happens at query speed. Another sort of more advanced topic, but
and there's just a follow on from that. Jake's put in: do segments and stroke partitions have headers like Parquet and Delta?
No. So the segment gets open, we jump into the column and we scan the column. So if there only happens to be one value in that column, it's a very short piece of data. But if it's randomly spread, like if segments just happen to have dates from anywhere, for example, we sort of scan for a bit, then stop, and then scan for a bit, then stop and do something, then scan for a bit, just to figure out what rows from elsewhere in that segment are relevant and should be used in the aggregation functions like sum, count, etc. So
Jake said like a dictionary scan.
Yeah, but I mean there is also value encoding. We are really starting to run. It's sort of it's a great question though.
Jake's done the optimizing DAX course with SQL BI and the tabular modeling course as well. So he's
nice.
a well knowledgeable speaker. Yes. Mark said, thoughts on the recent changes that improve summarized columns for use in measures versus the old patterns in terms of performance?
Like anything, just be careful. Like previously within a measure you could not use the summarize columns function, you could only use summarize. I think summarize columns gives you convenience, but it doesn't necessarily guarantee good perf results. I would still use exactly the same techniques I've shared today. Write your measure with summarize columns in that you previously couldn't do, but come back here and have a look to see what's going on with the covers. It may, for whatever reason, be generating an awful lot of storage engine events. And if that's the case, then you might want to try a different technique. So that's the main thing is what's going to be the effect on performance, and obviously making sure your results are accurate too. So I see it's convenient, it's nicer, it's tidier, I like it, but it doesn't necessarily guarantee that everything's going to be faster or not. So
yeah, they've put in the video from Jeffrey Wang in the chat for people to look at. So thank you. And there's a Tigger saying great. And they concur with cautions around summarized columns. Gina said the same. Lots of thank yous, and I think there was one more question I've missed, but I think we discussed.
Sue from Foamy about the matrix handle number of the rows.
Yeah, how does the matrix handle number of rows loaded to the visual when it comes to the large number of records? Is paging technique implemented here so it calls when you scroll down?
Yeah, so what happens is, remember I said let's focus on the summarized columns. This is actually running the query to go get all the results, but then the next query down immediately under the summarized columns, which is really just cosmetic, it's filtering it down to just 102 rows. So if I go back to my Power BI desktop and I scroll carefully, I will only see the first 102 rows ordered by whatever's hidden behind that tooltip. And then what will happen is when I scroll down far enough, it'll go and get the next 102 rows and the next 102 rows, probably execute the query actually.
Yeah.
So you'll see if you were tracing the database additional activity. So if your measures are slow and they take 20 seconds to load, I think when you scroll down and you might have a 20-second round trip to go there.
Yeah, I think that is all of the questions. That was just awesome. It was absolutely
fun. Thank you for inviting me. It's really nice to be up in this time zone.
Yeah,
I'm always happy to talk DAX.
I've already clocked that you're going to be around this time zone in Vienna, Phil. So you're penciled in for September.
Fingers crossed.
Fingers crossed. Fingers crossed. I'll be there too. We'll both will. But if we're there, I think we'll see what we can do regarding a catch-up session again.
Yep. And if any of you are down in my part of the world, New Zealand, hit me up. Let me know. There aren't that many people down there, so.
Well, that's probably part of the joy.
Sometimes, yes. It can be nice and peaceful. So
yeah, that was absolutely brilliant, Phil. Thank you so much.
No worries. Thank you all. Good night.
Brilliant. Yeah, good night. Around. Enjoy Newcastle. They go to the pub after. They're very quiet, and then they go to the pub, and then they're not.
Well, that could be good, although I have a 6 a.m. flight the next morning, so maybe just one.
Oh, well, have a fantastic trip and a safe trip. And thank you, and enjoy Copenhagen.
Cheers. Thank you. Bye-bye.
Thank you. Bye.
Thanks, Phil.
Bye.
Cheers.
Bye. Bye.
Thank you.
You're very welcome. What I will do, everybody, let me stop recording. Stop recording. So what I'll do